All right, ladies and gentlemen, welcome back. We are still in solving systems of equations. Our first method of solving, we said, was by graphing. So, for example, I've got a system here. There are the equations. Here are the lines. And we said that we would simply look for wherever our two lines intersect and that would be our solution. Today, however, we're going to use a different method of solving. Instead of graphing things, we're going to solve our systems by a method known as elimination. As the name would suggest, we're going to try to eliminate something, get rid of something, so that way we can get our solution. Elimination also goes by another name, linear combination. So depending on your algebra teacher next year, he or she might use one term or the other. You just need to be familiar with both. So elimination or linear combination, they amount to the same thing. So let's take a look. This system, for example, again, there are the equations. Here's the graph for it. Try solving that system real quick. So pause the video for a moment, see what you can do. What is the solution? And more importantly, why is it so difficult to solve? All right, so take a moment, see what you can do. All right, well, hopefully you recognize that there are a couple of things going on here, right? First, our equations are not in slope-intercept form. So this is a format known as standard form. I'll write that off to the side here. Standard form. And this is a format that, again, next year in algebra, you're going to spend more time with. For us here in pre-algebra, we'll simply dabble at it. Next year, you'll see it more. So first off, the form is off. Right? That's not a format that we are accustomed to. And second, and perhaps more important, the intersection is difficult to read. I mean, look at that. Is that half? Is that a third? Gee, I don't know. So this is the breakdown for graphing, folks. It works if, for example, our lines came at a nice, neat intersection. Problem is, not all lines do. As a matter of fact, a lot of lines don't. So graphing will only take us so far. With a graph, in this case, we could get close. I could say maybe it's a third up and a half over. I don't know. The best we can do is a guess. So here's the ultimate question for today. How are we going to solve systems like this one, where the graph is difficult to read and the equations may or may not be in slope-intercept form? And here is the answer. It's a very simple answer. Elimination. All right? In this new method that I'm going to show you, we're going to try to get rid of either the x or the y variable and ultimately be able to solve for the other one. Let me show you how it works. So I've put the system down here. I've just rewritten it for you. All right? Here's how the elimination method works. Here's your thought process. We're going to stack our system. All right, so notice there's one equation, there's the other. We're going to write it in a stacked format. What we're going to try to do is we're going to try to figure out, could I get rid of the x's or could I get rid of the y's by means of either multiplication or division? So let me show you something. I notice here that I have 6x, and here I've got 1x. Right? What I'm going to do is I'm going to try to eliminate the x's from both equations doing the following. I'm going to multiply this bottom equation by a -6. So let me show you what it's going to rewrite as. All right? Our top equation won't change. All right, so let's rewrite it here real quick. 6x doesn't change. 4y, that -4y, doesn't change. That 1 doesn't change. Okay, I'm just going to rewrite. But here at the bottom, watch what I'm going to do. -6 times x is -6x. Right? -6 times 7, a -42. Right? In this case, y. -6 times 4, -24. And then here's what we do. Notice that we've got a +6 and a -6. All right, we could have just as easily done it with the y's, but we're going to go with x to start. A positive and a negative. If I combine those together, in other words, I'm going to add the two equations together. By doing so, I'm going to eliminate the x variable. Take a look. Positive x plus a negative x, in this case +6 plus -6, zeroes out. There is no more x, it's gone. All right, let's try the next set of variables. I've got a -4y and a -42y. I can combine those. Negative plus negative is still negative. 42 plus 4 is 46y. Okie dokie. Keep going. Positive 1 plus a negative 24 is a negative 23. Now notice what's happened. I've eliminated the x. I've now gotten it down to, instead of 2 equations, I'm now down to 1. And to make it better, it's only a one-step equation. I can solve for y. Remember, when we're finding our solution to our system, I need 2 numbers. I need the x-coordinate and the y-coordinate. In other words, where this intersection occurs. I can now find the y-intersection, or at least where the y occurs. So I'm going to divide both sides by a negative 46. So 46 divided by 46, so that's just y. Cool. Negative 23 over a negative 46, well, that's a positive number. Negative divided by negative is positive. 23 over 46 simplifies to just 1/2. Or if you prefer a decimal, 0.5. Cool, so I'm halfway home. So this point is halfway up between 0 and 1 on the y-axis. All right, let's see if we can find the x. Well, now that I know the y, I can plug it in and get an answer. So take a look. I'm going to borrow this original second equation, all right, and I'm going to write it over here. Do our work over here. So x plus 7y equals 4. I now know what y is. So I'm going to take the y out and put 1/2 in its place. So let's rewrite it. X plus 7 times half, and I'm going to write it as a fraction just to save space, equals 4. Well, now notice I've got an equation with only x in it. I can solve that pretty easily. Half of 7, so x plus half of 7 is 3.5. I'll write it as a decimal here because I know most of you prefer that, and we don't have to save as much space now. To figure out what x is, we'll subtract 3.5 from both sides. So x equals 0.5, or 1/2 if you'd rather the fraction. And there it is. Our solution is at 1/2. So if we look at our graph, sure enough, that seems to be a reasonable approximation. We're halfway over and halfway up. The beauty of this method, though, is that I no longer need a graph. All right. I can solve my systems without the aid of a graph, find that solution, and I'm good. So let's review real quick. Here's how you do it. First, try to figure out if getting rid of x or getting rid of y would be easier. In this case, it made a lot of sense to try to get the x's to eliminate. I can multiply the bottom equation by a -6, and that way those -6's go away, or -6 and +6 go away. That's the whole point. I want to get down to just one variable. So in this case, I got down to just y. Once I solved for y, I could take that value, plug it into either equation, but I'm going to pick the easier one, plug it back in. Now I can solve for x, and we can get our solution. All right, let's try another one. Here in example 2, I've got 5x plus y equals 3, and -3x plus y equals -5. I notice that in this case, if I'm trying to get rid of something, I think y is going to be easier to get rid of. Notice the y's are almost identical. The question is, what am I going to multiply by? Notice over here we multiplied by -6 to get these to go away. What could I multiply by to make my other y disappear? Well, here's what I'm going to try. I'm going to multiply this bottom equation. And again, you could multiply by the top if you want, but I'm going to go with the bottom. I'm going to multiply everything by -1. All right, watch what happens. Top equation doesn't change. So this 5x plus y equals 3 business, that doesn't change. Let's look at the bottom equation. The bottom equation will. -1 multiplied by -3 is +3, so +3x. Right? -1 multiplied by a +1x is a negative, or excuse me, -1. Or x rather, that's a y. Negative y. So again, -1 times a +1y is a -1y. If I can keep my letters straight, goodness gracious. And then -1 multiplied by a -5 is a +5. Now watch what I can do. I can now add these together. 3 and 5x make 8x. A +1y and a -1y, they cancel each other out. It's like it never existed. On the other side, 3 plus 5 is 8. Cool. I can solve that. What number times 8 is 8? Well, that's easy. It's just 1. So if I'm looking for my solution, I already have the x portion of the solution. It's 1. Well, now I need to figure out the y. So what I'm going to do is I'm going to pick one of these original equations to plug it back into. In this case, I don't think it really matters. I'm going to try the top equation just to show you it doesn't matter. So I'm going to take that 5x, give ourselves some space here. I'm going to take that 5x plus y equals 3. And I'm going to take the 1 for the x and drop it in. So 5 times 1 plus y equals 3. All right, well, 5 times 1 is easy enough. That's 5 plus y equals 3. I'm going to go ahead and subtract 5 on both sides. That way I can get the y all by itself. 3 subtract 5 is -2. Cool. So in this case, the solution that we found, 1, -2, if we were to graph this, certainly wouldn't be one that would be difficult to find. However, we would have to take the time to rewrite these in our slope-intercept form, and then of course we'd have to take the time to graph it. Elimination is a lot faster. We don't have to spend our time rewriting. We don't have to spend our time graphing. We can just spend a couple of minutes figuring out x, figuring out y, and we're done. All right? Let's try a few more just so we can get a rhythm going here. All right? So take a look. Example 3. We have options. All right. Again, this is something for you to know. There are usually more than one way to solve a system. For example, in this case, one way I could solve this system is to multiply the top equation by -7. Because notice I've already got a +7 here. So if I multiply the top by a -7, I could eliminate the x's and then solve for y. Another way I could solve this is multiply either the top or the bottom, whichever, by a -1. That way making one of these positive and going from there. And I think that's going to be the easier method. So what I'm going to do is I'm going to multiply this top equation by -1. All right, we'll see what it gets us, and I'll write it over here. So the bottom equation doesn't change. So this 7x subtract y equals -3. That doesn't change. I'm just going to hold on to it. This other equation, however, is going to be altered slightly. -1 times x is a -x. -1 times a -1y is a +1y. And then -1 times 3 is a -3. And again, all we got to do is add them up and see what happens. Well, notice in this case, -x plus a +7x is just 6x, so we can write that down. +y plus a -y, well, those cancel out. And a -3 plus a -3 is a -6. Cool. Well, I can divide 6 on both sides to get get x by itself. And -6 divided by 6 is -1. Cool. So there's the first part of our solution, -1. All right, let's try for y. Again, which equation would be easier to work with? And in this case, I think that top equation is going to be a lot easier. So let's rewrite it. So x minus y equals 3. So that's that. Again, we could use either equation, but I'm going to try to use the easier one. We already know what x is, so let's plug it in. So -1 minus y equals 3. I'm going to go ahead and add 1 to both sides. That way that -1 goes away. So -y equals +1 and -1 0 out. +1 and +3 equals 4. Right? Got to get rid of that negative, so we're going to divide both sides by that -1 that's there. So y equals -4. Cool. Again, another intersection that would be pretty easy to read if we graphed, but that means we'd have to rewrite both of those equations and then spend the time graphing. Notice this one a lot faster. All right, so that's one reason why I like elimination, is it's a method that doesn't require near as much effort and also means that we can go a lot faster. All right, let's try another one. Example 4. Again, remember, there's usually more than one way to solve this. So there are a couple things I could do. One option I noticed is that I could multiply this bottom equation by 2. That way this 5 would become a 10. +10, -10, those would cancel out. Another way I can think of solving this is to take the top equation and divide by 2. You can use division as well as multiplication. If I divide by 2, this -10 would become a -5 and then be able to eliminate. So the choice is yours. How do you want to work it out? Personally, I think it's going to be easier if I take this top equation and do a divide by 2 bit. Notice that's going to make the numbers smaller, probably a little bit easier to work with. Not that multiplying by 2 is a terrible thing. It would work, But I think this is going to make our lives just a little easier. So let's rewrite that top equation. Negative 8 rather divided by 2 is negative 4. Negative 10 divided by 2 is negative 5. And then 24 divided by 2 is 12. All right, cool, so there's that top equation. All right, let's just rewrite that second equation. So in this case, the 6x, the 5y, and the 2 just stay put, nothing changes. And let's add them together. Cool. Well, negative 4 plus 6x, that would be 2x. The 5s cancel out, negative 5, positive 5, who cares? And then over here, 2 and 12 make 14. Looks good. So what number multiplied by 2 gives me 14? Well, that means x has to be 7. Cool. So let's start writing our solution. We know that x is 7. The question is now, what is y? Well, let's look. Of our two original equations, I think the bottom one is going to be a little bit easier to deal with. We don't have those negatives to fool with. The numbers are smaller. So let's use it. So 6x plus 5y equals 2. We already know what x is, though. So I'm going to take that x out, put 7 in its place. Now we can rewrite this and find y. All right. Well, 7 times 6 is 42, plus 5y equals 2. All right, we got to get y by itself, so 42's got to go. So let's subtract 42 on each side. So 42 subtract 42 is 0. That leaves just 5y. Let's see here. 2 subtract 42 is a negative 40. Okay. We got to get y by itself. That means dividing by 5. So 5 divided by 5 is 1. So we got that y by itself. Negative 40 divided by 5 is a negative 8, and there's our solution. Negative 8. So 7 comma negative 8, there's our solution for the system. Again, notice that would be a pretty easy one to read if we were to graph it. But again, look at these equations. They are not in slope-intercept form. They're in standard form. So we would have to sit there, rewrite all of this, graph all of this, and then define our solution. This method, much easier, much simpler. All right, now so far we've only had to adjust one of the equations. Take a look. Here we adjusted the top equation. Here we adjusted the top equation. On this side, we adjusted our bottom equations. Doesn't matter which one you do. But if you look at our last example, and this will be the last one that we do, this last example, there is no good way to just alter one of these to get what we want to have happen. So here's what I'm going to try to do. I'm going to alter both, all right? So let's write this out. You can alter both. There we are, both equations. That is allowed. Right? I noticed that the 4 and the 10 could easily, both of them, be made into 40. So here's how I'm going to do it. To this top equation, I'm going to multiply everything by 10, just because multiplying by 10 is a very easy thing to do. So we're going to multiply everything by 10. So let's do that real quick. So 11 times 10 is 110x. 4 times 10, that's 40, in this case y, and then 10 times a negative 36 is a negative 360. Cool, multiplying by 10 is easy. Let's look at the bottom of it. In order to get this to be a negative 40, that way the y's will eliminate, I'm going to multiply everything down here by negative 4. Again, not a bad number to work with, and I ultimately put this down here because I didn't want to have to multiply something weird up top. So let's do it. Negative 4 times 10 is negative 40x. Negative 4 times 10 is negative 40y. And then negative 4 times negative 20 is positive 80. There we go. All right, so now that we've rewritten everything, now we can start adding them together. All right, so let's start that addition process. And again, be careful with the negatives, folks. We don't want to do something silly. 110x added to a negative 40x would be 70x. Right? Notice our positive and negative 40s, those cancel out, so no need to worry about those. And then I've got a negative 360 added to a positive 80, so now our answer is going to be negative in the end. So if I take a negative 360 and add it to positive 80, that's a negative 200. If I can get my pen to write, negative 280. Cool. So there we are. Again, the numbers are larger than we would like, but not the end of the world. Notice we did get rid of y. Now we can find x without any real big deals. All right, so let's see what we can do. We need to divide both sides by 70 in this case. So x equals, if I divide by 70 over here, I know 7 goes into, oh, it's going to be negative, so let's write that down. Positive and negative divide out, still negative. 7 goes into 28 4 times, and then of course we'll eliminate both those zeros. So it looks like x is a -4. Cool. So let's write our solution down. -4, comma, now we need the y. Here's what I recommend you do. I'm not going to use either of these equations that we rewrote. I'm going to go back to the originals. The numbers tend to be smaller, and not always, but typically are easier to work with. In this case, I'm going to pick the bottom equation just because 10s and 20s are very simple numbers to work with. Not that the top numbers are bad, but these are just easier. So let's grab that bottom equation. 10x added to 10y equals -20. I already know what x is, so let's substitute it in. 10 multiplied by -4 plus 10y equals -20. So here we go. -4 times 10, well, this seems familiar. -40 plus 10y equals -20. Looks good. Let's go ahead and add 40 to both sides. That way this will be eliminated. Remember, we're trying to get y by itself. So if I add 40 here, it zeroes out. So 10y. If I add 40 to the other side, 40 plus a -20 is just 20. Cool. Let's get that y by itself. So we'll divide both sides by 10. So 10 divided by 10 is 1. So that's 1y, almost off screen there. And then 20 divided by 10 is just plain old 2. Cool. So there's the solution. -4, comma 2. Again, I know some of you might be looking at this method and going, holy crap, what is that? But again, think about it. If I had to graph these, I have to rewrite them. Once I rewrite them, then I have to graph them. So you're already doing a bunch of algebra here to get it rewritten. You're having to do a bunch of algebra here to get it rewritten. Once you've got it rewritten, then you're going to spend the time graphing. And while you're doing all of that, I can very simply do a little multiplication, a little addition, boom, first part of the solution found. Little substitution, touch of algebra, boom, second part's found. I can be done doing this method, and so can you, quicker than if we had to sit down. Let's see if we can get that to focus. There we go. Quicker than if you had to sit down, rewrite all of this, graph all of this, and then figure out where they cross. All right? We'll spend some time in class today doing more examples. Guys, remember, if you're having any questions, please make sure you write them down on your notes. That way, when you come to class, you can share those with me, and we can get those questions answered. All right? We'll see you in class. Have a good day, folks.